Okay, this video is just going to be example problems. So we'll start with one where you have a bridge. I can't really think of what a side profile of a bridge looks like. And you have this person with badly broken fingers sitting on the bridge. That's his hair. And he wants to know how high this bridge is. So he drops a rock and times how long it takes for the rock to hit the water. So we're going to say that the rock takes 1.2 seconds to hit the water. How high is the bridge? And I want you to notice that the approach for problems like this is exactly the same as it was for the car problems and the ball rolling on the ramp problems. We're going to place the zero of a number line where the object is when you turn on the stopwatch. And I'm in free fall and projectile motion problems. I'm always going to make my positive up and my negative down. That's just what I'm used to doing. And so we're trying to figure out how far in the negative direction the water is from where it's dropped. Okay, so what do we know? At time equals 0, that's when we turn the stopwatch on. We know that the position is 0. That doesn't come into any of the equations. I'm not going to write that. We know that the velocity, and that's what we call v sub 0, is equal to 0 because it's dropped from this bridge that doesn't have any velocity. And then for our time t, we're trying to find the position. We don't know what that is. It has some velocity. We don't care what that is. And then through all of this, we know that the acceleration is down at 9.8 meters per second squared. Since down is our negative, this is negative 9.8 meters per second squared. Okay, so what do we know? What are we trying to find? We know that, and I didn't write this, but we actually know what this t is, right? We know that this is 1.2 seconds. So, okay, we know that t is 1.2 seconds. We know that the acceleration is negative 9.81 meters per second squared. We're trying to find p, and we know that the initial velocity is equal to 0. So let's think about our 3 equations. The first one says v is equal to v sub 0 plus at. The second one says p is equal to v sub 0 t plus 1/2 at squared. And the third one says 2ap is equal to v squared minus v0 squared. I'm going to copy this and just paste it in each one of these problems. Okay, so is there a one of these three equations that works for solving for p, given what we know. It looks like we can use the second equation. So the second equation says p is equal to 0 times 1.2 plus 1/2 times negative 9.8 times 1.2 squared. And if you calculate that, you get an answer of negative 7.06 meters. You know, a meter is a little over 3 feet, so that's, you know, say 22 feet or something. Does it make sense that we got a position that's negative? Yes, if you look at this, you can see that since R0 is where it's dropped from, the water has to be, and you know, our positive was up, the water has to be in the negative direction from 0. So we expect to get a negative answer, and the magnitude, the absolute value of that answer is the height of the bridge. The next example, let's say that a ball is thrown straight upwards from a height of 3 meters. At the instant it's released, the speed is 10 meters per second. And we want to calculate the following things. First, how high is the ball at its highest point? Second, what's the ball's velocity? When it returns to a height of 3 meters. So it's going to go up from 3 meters, reach a highest point, start coming back down, and when it returns to the height it was released from, we want to know what the velocity is. We're going to actually see something here that is always true, and I'll bring that out when we get to it. What's the ball's velocity when it reaches ground level? Okay, we're going to have to choose different instants, like different times that the stopwatch says for each one of these. So we're going to sort of think of these as 3 separate problems. So starting out with part A, we want to calculate how high the ball is at its highest point. So we're going to turn the stopwatch on. Time equals 0 is going to be when it's thrown. At that instant, we know that the velocity, that's what we call v sub 0, is going to be, well, the speed is 10 meters per second, and then you have to think, is it moving in the positive or negative direction? Like I said in the last example, I'm always going to choose my positive up for these problems. This is being thrown straight up, so this is positive. And then for our time t, we want to calculate the position. We don't know what that is. We do know that the velocity when it reaches the highest point is 0. That was one of the 2 facts I said that we're going to use pretty often. So anytime in a problem it says something about an object getting to its highest point in its flight, you know that at that instant the velocity is equal to 0. And through this whole thing, we know that the acceleration is negative 9.8. That's 9.8 meters per second squared down. Okay, so let's think about what we know and what we want. We don't know how long it takes. If we can do it, if we don't have to calculate it, we can skip it. We're not asked for it. So I'll just leave that out for now. We know the acceleration is negative 9.81. We know that, let's see, well, we're trying to find the position. V sub 0, we know, is positive 10 meters per second. And V is 0. Okay, so I'll copy these 3 equations down here. And we have to think, is there any one of these 3 equations that lets us calculate that P? Neither of the first 2 work because we don't know the time. But I think this third one should work. So if we plug this stuff in, we get 2 times negative 9.81 times P. I guess in this class I'm using 9.8 times P. And that's equal to 0 squared minus 10 squared. So that says negative 19.6 P is equal to negative 100. Divide both sides by negative 19.6, and you get that P is 5.10 meters. Okay, well, it doesn't ask how much higher the ball goes. It asks how high the ball is, which implies above the ground. So now you also have to think, okay, our 0 is where it was released from, but that was already 3 meters high. And so the height of the highest point is 5.1 plus the starting 3, and so the height is 18.1 meters. So now for the second part of this, we want to figure out the velocity when it returns to a height of 3 meters. We're still going to turn the stopwatch on when the ball is released. So at t equals 0, what we know is that v sub 0 is equal to positive 10. And then at the height t, at the time t, what do we know? We know that the position, this is when it returns to a height of 3 meters. Well, in other words, it returns to the height where we put our 0. And so this position is 0. we're trying to calculate the speed v. And all of this happens with an acceleration of negative 9.8 meters per second squared. So let's think about what variables we know and want. We don't know how long the time is. We know that the acceleration is negative 9.8. We know the position is 0. We know that the initial velocity is positive 10 meters per second. And we're trying to calculate v. So is there an equation out of these three that we can use? Whoops. Try that again. Okay. Well, again, we don't know the time, and so if any of these work to calculate v, it has to be the third one. So let's try that one. 2 times negative 9.8 times the position of 0 is equal to v squared minus v0 squared. This goes away because you're multiplying it by 0. And so what you get is that v squared is equal to negative v0 squared. No, that negative. So basically, what I did is kind of add v0 squared to both sides and then just switch the sides. And so if you take the square root of both sides, what you get is v is, when you take the square root, you have to take into account the plus or minus. So v is plus or minus v0. So now you have to think physically, which one of these do we want? When the ball returns to the height of 3 meters, returns to where it was thrown from, is it on the way up or on the way down? In this case, it's on the way down. And so the velocity when it returns to that height is negative 10 meters per second. And it seems like maybe kind of a funny coincidence, but that's how free fall problems always work. So if something is launched upward, the velocity when it passes any given height you choose is going to be a positive number, and the velocity when it returns to that height is going to be the negative of that exact same number. One thing that makes you think is that's why you don't want to shoot bullets straight up into the air. That's why, cities say, like, do not do that. A bullet that you shoot up at 1,000 meters per second, if you ignore air resistance, and of course there's air resistance because it's moving really fast, but just as a first approximation, if you shoot it at 1,000 meters per second upward, when it returns to the height that it was fired from, its velocity is going to, it's going to be at a speed of 1,000 meters per second, now just in the negative direction. And that obviously does a lot of damage. And the last part of this, what's the ball's velocity when it reaches the ground level? Again, we're going to turn the stopwatch on when this thing is thrown into the air. So that's going to be our time equals 0. We know that v sub 0 is equal to positive 10 meters per second. And then we're going to look at the stopwatch again when it reaches ground level. Now, we're not going to consider the fact that when it gets to ground level, it hits the ground. We're going to pretend that the ground isn't there, and we're just trying to calculate stuff as the ball passes that level. Okay, so what do we know? Well, we know that the position at that instant is 3 meters below where it was thrown from. That's 3 meters in the negative direction from what we called 0. And so this position is going to be -3. The velocity we don't know, but that's what we're trying to calculate. And all of this, of course, happens with an acceleration of -9.8 meters per second squared. We don't know the time. We do know the acceleration is -9.8. The position is -3. The starting velocity is +10 meters per second. And we're trying to calculate v. The equation we're going to use here is just the same one we used in B. We just had some slightly different numbers. So 2 times -9.8 times a position of -3 is equal to v squared minus 10 squared. If you multiply out the left side, you get 58.8, and that's equal to v squared minus 100. Add 100 to both sides, and you get that v squared is equal to 158.8. Take the square root of both sides, and you get v is equal to plus or minus 12.60 meters per second. Now, to think about whether you want the plus or minus, you have to think, is this on the way up or the way down? We're talking about after it's reached the highest point and now it's coming back down to the ground. So it's moving in the negative direction, and so we want the negative. And it makes sense that the speed would be a little bit higher than the speed from part B, because it reaches that height of 3 meters, and then it continues speeding up on its way down until it reaches the ground level. For the last one, let's imagine that there's a person standing on a ladder. Don't ever stand on a ladder like this, by the way. But it makes it easier to draw. Okay, so this person's standing on this ladder, and then they're throwing a ball down towards the ground. Okay? And we'll say that the height that the ball was released from is 4 meters. So this distance is 4 meters. So this ball is thrown downwards. Straight down. From a height of 4 meters. And it takes 0.4 seconds to hit the ground. And the question is, what was the speed of the ball at the instant it was thrown? Well, like I'm always going to do, I'm going to choose my 0 to be where it was thrown from, and my positive to be up, and my negative to be down. I'm going to turn the stopwatch on when the ball was thrown. And then I'm going to look at the stopwatch when the ball reaches the ground level. So the time equals 0 is when the ball is thrown. We know that, let's see, what do we know? We don't know anything about the velocity there, but we know that we're going to call it v sub 0. And then at the instant that we look at the stopwatch, when the ball reaches ground level, we know the position. We know that the ball is 4, like if you start at 0, to get to the ground level, you go 4 meters in the negative direction. So P is equal to negative 4 meters. We don't know the velocity when it reaches the ground. And we know that over this whole interval, the acceleration, we do know one more thing, but we know the acceleration is negative 9.8 meters per second squared. The other bit of information we know is that we know in this case what the stopwatch says. In the last example problem, we weren't given that information, but we know that the stopwatch, when it reaches ground level, says 0.4 seconds. All right, so let's think about the information we're given and what we're trying to find. We know that the stopwatch says 0.4 seconds. We know that the acceleration is negative 9.8 meters per second squared. We know that the position is negative 4 meters. And we're trying to find v sub 0. So I'm going to put this in here again. That formatting's all screwed up. Okay, forget that. I'm not going to put that in there. But if you go through those equations one by one, you can see that the equation that has v sub 0 in it and everything else is known is this one that says P is equal to v0 times time plus 1/2 times a times time squared. Put in all the things you know, and you get negative 4 is equal to v sub 0 times 0.4 plus 1/2 times negative 9.8 times 0.4 squared. So negative 4 is equal to 0.4 v0 minus, if you multiply out this term, 0.74. And so let's see, if we add the negative, if we add positive 0.78 to both sides, we have negative 3.22 is equal to 0.4 v0. Divide both sides by 0.4 and you get that v sub 0 is equal to negative 8.04 meters per second. Now it's worth thinking for a second, does that sign make sense? In any case where the sign is given to you, that can sometimes help you figure out whether something went wrong in your calculation. In this case, this ball was thrown straight down. We're calling that negative, so it does make sense that when this ball is thrown, it has a negative velocity. The problem asks for the speed, not the velocity, and the speed then is just the positive of that velocity, the absolute value. So 8.04 meters per second is the speed that the ball is thrown down.